I got the visual, all looks good. By the way, the view is amazing from here. And it looks like my next communication with the Earth has just started. Hey guys, can you hear me? Let me get inside, give me a moment. Alright, I'm back. Hello, I'm GeneUs programmer, and this is Crazy Algorithmics. Welcome to my channel, or welcome back if you've been here before. Either way, it has been a few weeks since my previous video, and today I'd like to continue where I stopped last time. If you haven't watched my previous video about array traversal, you may want to do it before this one so you know where I'm coming from. I will put a link in the description below. Let's start with a very quick and a very useful exercise. It will help you to check and develop your fine motor skills. Take your dominant hand like this and do this move. You see? Like so. Now put this claw, so to speak, on the top of your mouse or a trackpad, whatever you're using. Find this like button on the screen and do click. And just to make sure you are consistent with your action, find a subscribe button on the screen and do click. This helps me to make my new channel more noticeable and helps you to stay in touch and receive more crazy content, like the world is not crazy enough yet. Alright, let's get started. If you are familiar with the graphs, you may want to skip the first half of the video. Or if you just want to see a C# implementation of this code, you can find it in my repo. The link is in the description. I won't be going over C# version in this video because it is very simple. Now, back to my crazy Mars story. If you remember, during my imaginary mission to Mars, we discovered an ancient maze with an artifact located somewhere there. So last time I was traversing a scanned image of the maze to get a path to the artifact. Today I'll continue working with it, and I will start with the final version of the real map of imaginary ancient maze from the last video. That's why you need to watch that previous video if you haven't, so you know how I got it. In the last video, I used breadth first search, or BFS, to get the shortest path from the beginning of the maze to the goal. I used letter to indicate east, west, north, south, and it worked fine. However, this method has a couple of flaws. First, it was based on an assumption that every step we take was equally easy. Of course it was. We were just traversing the array. But what if one path has difficulty level equal to 1 and the other one equal to 10? The second assumption was that every path was a bidirectional, so it means we can travel both ways. What if that's just a one-way street? We send the rover, it can go down to the lower level but won't be able to get out. I'm sure you already know where I'm going with this. In this video, I'd like to talk about graph, a very useful data structure, very practical. It is used to represent the relationships between different pieces of data. In fact, I will be making several videos about graphs. Some of you may be using graphs every day without even thinking about it. Street map or GPS application is a good example of graph. Finding the fastest, shortest path from point A to point B, taking into account distance, direction, one or two-way streets, traffic, temporary obstacles, etc. Every social media site is based on the graph. Not only it will show you your friends, but will also make suggestions who you may want to know based on your connections. That suggestion mechanism is a close cousin of recommendation engine. What the customer may buy based on their purchasing history. That's a huge one right now, especially with all the shopping shifting online. We can go into electrical engineering, like modeling circuit connections, into physics, chemistry, biology. Or how about this hot topic for today? What was that? Oh, that's the one with muzzles. I don't want to say it out loud just in case a big brother is overseeing this. We don't have it here on Mars due to sufficient social distancing, obviously, but I've heard it has been going on Earth. That's one of the topics I will be covering in my data science videos. In this video, I'll be talking about making a graph out of array. Just like the last time, I will program in Python with the final code also available in C#. Below you can find a link to my Git repo with the examples I'm giving here. But most of the video will be explanation why I did what I did. It's not that much of a coding going on here. I like using Python for these videos because it is almost as easy to follow as a pseudocode. In the first half of the video, I'll work with a single level maze, the one I used last time, and talk about what graph is. And the last part will be about something more exciting. We'll create a multi-level maze and of course process it. This is a maze map from the last video. And the array that represents it, I use zeros to denote ground and ones to show the passage. And the result of BFS was very accurate, but not very informative. As I mentioned earlier, it is based on assumptions. The shortest path may be too difficult, or it may be too narrow for a specific rover, or too low. Or it may be one-way path where the rover would have to drop to the lower level but won't be able to come back up, and we have to consider those factors. The way I will try to solve today's maze is depth first search or DFS approach. We will travel as far as possible before returning back. My goal is making a graph of the entire maze. Another concept you need to keep in mind is the order of processing. There are three main approaches called in-order, pre-order, and post-order traversal. I won't go into details here. There are plenty of videos online where you can learn about it if you don't know already. I will be using pre-order approach. What it means, I will first process the node I'm stepping into. Then I will go into each child node. For example, I have this simple structure. I will start with 1, process it, then go into 2, process it, then 4, then 5, and then I go back to 3. I need to determine what each spot is before I attempt moving any further. Is it just a passage or a fork where the passage splits? Here's what I will do. I will mark these points on the map where the path splits into 2 or more as intersections or forks. I'll call it node in this video. Each node will hold a collection of connections to other neighbor nodes. If we look at this blue path, point A will hold connection to north, which is a dead end, west, and south. Point B will have 4 connections in the list, all 4 directions. A has connections to B and B has connections to A. Unless the path is one way only, then A to B may have a connection, for example, and B to A won't. First, I want to take this array as is, and instead of traversing it to find the path, as I did before, I want to traverse it to create a graph. So this is what I expect coming out of my traversal algorithm. In order to make a graph, I will need 3 classes. Graph itself, of course. It is just a container to hold a collection of nodes. Each node will have a collection of connections to adjacent nodes. We call them edges, and each edge will contain some information relevant to that path, like moving steps, of course, difficulty level, maybe height, width of the passage, etc. I will put data relevant to the maze I'm trying to walk through. I will start with the edge class. Since I am replicating the array traversal I worked on last time, my edge class will hold a list of steps as a list of directions, north, south, east, west. So these are 2 methods I need to have. Init, where I will declare an empty list, and add step. Yes, that's all I need to get started. Overriding toString and getting a path as a string are two methods I created for convenience just to keep transformation inside the same class as data. This edge is not weighted. It only holds the steps. Like I said, I'm just replacing my last BFS with DFS or depth first search and graph. Our next class is node. The node does not have any knowledge about what happens on the path. It has a key, a value, and a list of connections or edges. We can add a connection and we can get connections and get an ID of the node. These are just very basic operations. We can add some methods like delete connection, rekey, change value if we really need that. But for our simple example, this will be sufficient. Also notice that here I made it really simple. I'm not adding edges as objects. I'm adding a string representation of the edge. That's the reason I created those methods to convert edge to string in the edge class. I'm using string for simplicity here. A graph class has a little bit more logic. As you can see, I'm creating an empty collection of nodes. AddNode method will check if the node with specific key is already in the collection, and if it's not, then let's create a new node and add it to the collection. GetNode is the one checking if the node exists. It returns either node or none, which is denoted by the optional type. Overriding DoneTheContains method will allow us to check if the node is in graph as opposed to if node is in graph.nodes, just a convenience item. AddEdge is what actually is adding a new connection. We need to pass two IDs, from node and to node. I will check each ID, and if node does not exist, create a new one with this ID. Then add a connection to the one specified as from node. Please keep in mind that I am not adding a reverse connection by default. I will do it later manually for each node. GetNodes returns a list of node keys, imagine that, and toJSON will serialize the graph object into a JSON string. As you can see, the basic graph structure is very simple. If you watch other videos online talking about graph, then you'll find out that this type of structure is known as a JSON list. Since I don't have a real rover, nor do I have a real maze, I will rely on the same array I created for my previous video. That's what we'll be working with. And finally, here's my modified traverse map class. I will initialize it, setting graph to a new graph class and data to none. Traverse is the only public member in this class. All others are private, even though in Python, as you may know if you work with it, all private-public business is just a matter of convention, an agreement not enforced by the language. Map data is an array, and it will be converted into NumPy array because it's much faster than a list of lists. My entrance point will be a node no matter where I get in. Even if I enter at the dead end, which 0 point actually is, and it only has one passage, but I need to keep track of its coordinates, and the node is the only structure that will. So it is the initial node. The value will have to be set as B to show beginning. Or in case if we drill the hole and see the goal right there, just got lucky, then it will be set to G. In my array, it is represented by number 8. The initial edge will be set as an empty edge class. Now I will make an initial point with coordinates 0, 0 and current value, most likely B, and call my recursive private underscore traverse function, passing initial point, newly created empty edge, and new node as arguments. After all recursions are done, I can return a graph object as a result. Easy. The recursive function is where I had to spend most of my time writing this code. I wanted to make it non-complicated solution with minimum of code. Here's what I got. I'm sure if you work on it, you can modify it and make it even better. I'd love to hear from you if you can solve it easier. Put your comments in the comment section under this video. First section is easy. I'm unpacking a tuple and composing a key of the current spot in case it is a node and I will need it later. So from my initial call, this will be 0, 0B, and the key will be 0, 0. That's easy. Now here's where it gets a little tricky. The initial call is the only time when I process the node which will not be even identified as a node by later code. And the ID of from node and current ID are the same. I will show you later how I solved it here. Let's go to the next line. I have to decide if this particular point is a fork or just a passage. For that, I will get a list of child points, just like I did in my BFS algorithm in my last video. Let's look at it. This underscore getChildPoints will check point in each direction, north, south, east, west, and determine if each point is open. And if yes, it will add it to the list, and then return the list. Underscore is open function will check if the point is within boundaries, and if the value is not 0, that's it. This is exactly the same function I used in my video last time. Next line, however, is totally new. If you remember from the previous video, I was setting every point equal to 0. I did it to avoid visiting the same spot twice. This time I modified it. Here's what it is doing. Let's look at this function I called reverse off. I know this is not the most optimized solution with hard-coded if statement, but for my simple example, this will do. This function will look at the direction and return the opposite. For example, I'm coming north. Then in order to go back, I would have to go south, and vice versa. It is doing that for every direction except when I pass B or G. Then it returns them unmodified. Here's how I use it. Once I get all available points, this list comprehension will process every available point. And remember, those are tuples with row, column, and direction, and I will return points where this x with index 2 or direction is not equal to reverse of current path. Yes, that was my original idea. Perhaps not the best, but it works just fine. Let me explain by giving you an example. Here's point A, and to get there I went east, so current direction is set to E. From point A, I have 3 possible directions, north, east, and west. So these 3 directions will be returned as available points. However, since I went east, the reverse of that is west. So this list comprehension in this case will be saying, give me the list of points where direction is not west. Of course, why would I go back where I just came from? So child points will only have 2 items, north and east. That's what I use instead of marking the spot with 0 like I did in my last video. The next function, mark spot, is a nested function. Yes, I could have used a separate method or even a separate class. I wrote it as a nested function only accessible from inside my underscore traverse function for the sake of doing it this way, just to show you that Python can do it. And so I could use variables inside the scope of my recursive function. I will get to it a little bit later. Actually, I will get to it right in my next if block. I am checking here if the current key is already in the graph, which means I've been there already. Now I'm calling this mark spot function. This function will get a string representation of the current edge, meaning the sequence of steps from the previous node to the one I'm standing in, and it will add 2 edges, from the previous node to the current and from the current to the previous. But it has to be a reverse passage. The underscore reverse path function not only reversing the sequence, but is using the same reverse of function to get a reverse path. For example, if I have a list N and E, then simply reversing it into E and N won't do the job. It has to be WSS. It has to be a reversed path, not just a reversed list. And that's what the function is doing. It is getting a reverse path and connecting the current node with the one I came from. Remember I mentioned earlier that adding the list node with coordinate 0, 0 could be a little tricky? This is how I solve it. If direction is not B, meaning it is not the beginning, then return, means finish the recursion. Get back to the previous node and try next path, since this one is done. But if the direction is B, then keep going like nothing happened. B node with coordinates 0, 0 was already inserted. My next if statement is checking if I reach the goal, which is number 8 in the array. If it is, mark it as node with value G, means goal, and finish current recursion. This one, however, can be a reason this algorithm will fail. I will tell you the reason and let you find a solution if you want. Let's say there's another artifact behind the first one, and it is a dead end. But the algorithm will never go there because it backtracks after reaching the first goal. So instead of returning after finding the artifact, we may need to process it further. I will leave it up to you. The final set of if instructions is making a decision whether a current point is a dead end, a one-direction passage, or a fork or intersection. The decision is made based on how many available routes this point has, not counting the one I just came from. In case of dead end, I add a node with value DE, means dead end. Smart, huh? No, genius. One valid path means it is just a corridor, so keep going. I'm taking this first element of the list because, if you remember, I'm using a list comprehension to retrieve the child points, and it is always a list. So single child point will be returned in the form of a list with one element. When I'm unpacking tuple, I use underscores instead of two variables. It means I'm only interested in direction here, and underscores are unused variables. It tells Python that, yeah, I know there are variables there, but ignore them and take the third one. I'll show you another technique later. Remind me to do that. Then I'm adding a current direction to the current edge as a step and call the reverse function again using a new point, the same edge, and the same node. The final else section is catching all the cases that have more than one child point. It will mark the spot as we did before, meaning set it as a node. I should have called it something more like mark node. You can rename it if you like. Now I will iterate through the list of child nodes. I will create a new edge for each child node. Remember, this is a new node since it has several passages out of it, so new edge for each new passage. Instead of unpacking the tuple like I did earlier, I will simply grab the third element of it. Thanks for reminding me. It will do exactly the same thing as the one above. It will add the current direction to the edge. I just put it all in one line, and then it will call the function recursively. All three sections call this mark spot function. That's why I put it into the nested function. Everything keeps going until all possible ways are documented, so to speak. Now, if I create an object and call traverse function, remember it returns the final graph. I can iterate and print values of each node. Here's what I get. Yes, 0, 0 added a connection to itself because that was not a standard node. I can either forgive it such a sentimental behavior or put a check in the code. If path is an empty string, then don't add it to the node. I'll just leave it as is for right now. Let's look, for example, at this 1211 node. The map has 4 passages connected to it, one in every direction. Let's look at the printout. Indeed, it has 4 items in the connections, and that all is correct. 1414 is a node because I asked the program make the node out of dead end. And we'll look at the printout. The node 1414 indeed has a value DE, and is only connected to 1211 with a reverse path. It looks pretty good. The only thing I will modify in this class is a starting point. Here's a small modification. I added two optional parameters to the constructor, and in the main traverse function, I will use that initial data as starting row and column. Everything else is the same. This would qualify as a solution for traversing array into graph, but this sure is not quite enough for exploring ruins on Mars. I'd like to make it hopefully a little bit more interesting. Let's imagine that the maze we discovered has more than one level, maybe two, maybe more. We have no idea how many, so we don't want to send a rover right away. We will send a drone. This is not a joke. NASA is actively working on operating a drone on Mars. You can find some recent footage online. In fact, I will put a link under this video. I thought it was fascinating. So let's imagine we send a drone to explore the ruins before we can send the rover. The job of the drone is to scan the passages and give us some data we can use. Here's an updated map of the maze. I made yellow upper level, call it level 0, and blue a lower level, which is level 1. I called it like this simply for convenience, since this will be just another dimension in the array, and the array is 0 based, of course. The spots where yellow and blue intersect are connections between levels. There you can go up and down. Well, the drone can. As far as the rover, we'll have to decide it later based on the data we get from the drone. First of all, now we need to make our array three-dimensional. Instead of creating a list of lists, I will create a list of lists of lists. That's a mouthful. Anyways, this is the array representing level 0, the yellow one on the map. And here's the level 1, which is the same array I used last time in a single level array traversal. To create a 3D array, I will simply make a list of two elements. That's it. Remember this 3D array I used in my last video to show how the structure of the image looks like? Well, here I just used 2 layers instead of 3, and I made the top layer yellow, not red. The class TraverseMap3D is essentially the same as the last one I wrote, but I had to make some modifications to take into account another dimension. As far as graph class, node, and edge, nothing has changed. Can you believe it? Let me quickly walk you through some changes I made to Traverse class to work in 3D space. Class initializer or constructor is now taking 3 optional parameters. Traverse function is doing exactly same stuff as before, except it is looking up data using 3 indexes. The key is constructed using 3 numbers instead of 2. Everywhere I use 2 indexes to access data, I'm using 3. Of course, I had to modify child point search because now we have up and down directions, which I marked as U and D accordingly. And reverse of function has to consider up and down directions as well. That's it. You can find all this code in my repository. The link, like I said, is in the description under the video. I will also add a C# code for this final version of our little application. I won't be discussing C# code today because it is very simple and totally mimics what I already showed in Python. Now, if I process my maze 3D using this class, I'll get exactly what's expected, a list of nodes with the keys, values, and connections. I think this is a good spot to take a break because we just received some good data from our drones, and I'm very curious to look at it. Okay, seriously, I think this video becomes too long. If you haven't exercised your finger yet, the way I showed you in the beginning, please do so. Leave a comment below with your ideas regarding graphs. Ask questions if you have any, or maybe make suggestions regarding the other Crazy Algorithmics videos. This all helps me to create more interesting content, grow the channel, and bring more Crazy Algorithmics into the world. That's it. Stay safe, keep learning, go program something really awesome today. Remember, we're not programmers, we are world changers using coding as a tool. It doesn't matter where you are on Earth or on Mars. Make a wonderful day happen, and I will talk to you next time.